In traditional Java, every platform thread is directly mapped to one operating system thread. So if your application creates 10,000 threads, the operating system also has to manage 10,000 OS threads. That's expensive. Each thread needs its own memory. The operating system has to constantly switch between thousands of threads. And as the number of threads grows, context switching overhead increases. Eventually, you'll hit your operating system's practical thread limit, making your application harder to scale. Java 21 solves this problem with virtual threads. Instead of creating one operating system thread for every task, the JVM creates lightweight virtual threads. These virtual threads are then efficiently scheduled over a small number of operating system threads. This means you can create thousands, or even millions, of virtual threads without creating millions of OS threads. That's why virtual threads dramatically improve scalability and allow Java applications to handle massive concurrency with far fewer system resources. Now here's one of the most common Java interview questions. What's the biggest difference between platform threads and virtual threads? With a platform thread, one Java thread maps directly to one operating system thread. With virtual threads, thousands of Java threads can share just a few operating system threads, because the JVM schedules them efficiently. If you remember just one thing from this video, remember this mapping. Platform thread, one Java thread, one OS thread. Virtual thread, thousands of Java threads, few OS threads. That's the biggest difference. So, should you use virtual threads everywhere? Not really. Virtual threads are ideal for applications that spend most of their time waiting rather than computing. They work best for REST API calls, database queries, file operations, network communication. In these cases, virtual threads allow your application to handle many more concurrent requests while using far fewer system resources. However, for CPU-intensive tasks like image processing, video encoding, or complex calculations, virtual threads won't make your code execute faster. The key takeaway is simple. Virtual threads improve scalability by handling more concurrent tasks, not CPU performance.